Now let's switch gears and look at solving basic exponential equations. Now, we've already solved some basic exponential equations when we were in the exponential section, and that's the types of equations where you could write the same base on either side of the equal symbol. But now let's look at some problems where we're going to have exponential equations where you can't write both sides in terms of the same base. So again, we're going to start out a little more basic in this section, but once we hit a later section, we're going to get a little more complicated types of problems. So make sure that you really practice these now. So the steps for solving exponential equations of base e or base 10 are to isolate the exponential part. So same kind of deal that we did with the logarithmic ones where we isolated the logarithmic part first. Now we're isolating the exponential piece first. And once that's isolated, then we can actually change it into a logarithm. And then you're going to use either the log key if it's log base 10 or the natural log key if it's log base e to evaluate the variable. Now, the big thing is if you are using a TI-89 calculator, the log button isn't actually on your home screen of your computer. So one shortcut that works for most operating systems for the TI-89 is if you hit the green diamond and then the 7 key. Or the 7 number, and that'll bring up logarithm. However, if you want to, you can just go to desmos.com, and when you go to that website, you'll see they have, before you hit the start graphing button, right underneath that, there's a scientific calculator place that you can go, and they have this, all of these there as well. Okay, so some examples. So looking at letter A. Again, you can tell these are exponential functions or equations because we have the variable in the exponent. So right now that x is stuck in the exponent. I have no way of writing 110 in terms of base 10. So the first step you always do when you see an exponential equation is see if you can get both sides of the equation to the same base, because that's the simplest way to do these. Unfortunately here I can't, so now I'm going to follow these steps. So isolate the exponential part. The exponential part's already isolated. Now we'll change it into a logarithm. So log base 10 of 110 equals x. Now remember, log base 10 is just log, so I actually didn't even need to write this. And now all you need to do is either go to your calculator or go to using some type of technology to evaluate this, and you end up getting the log of 110 is roughly 2.04. Now again, on an exam, if I asked you for an exact answer, that would be the exact answer. And if I asked you to approximate, this would be approximating. Okay, letter B. So this right here is the exponential piece. So that's what I need to get isolated. So the first thing that we'll do is we'll add 2 to both sides. 3 e to the 2x plus 1 equals 12. Now I need to get the e by itself, so I'll divide both sides by 3. E to the 2x plus 1 equals 4. Now I actually have this exponential part isolated. So now I can change it into a logarithm. So this is going to be log base e, which is the natural log, of 4 equals 2x plus 1. Now my best advice for these is to not put this into your calculator until the very end. So don't approximate anything until you're absolutely done with solving for x. So the first thing that I'll do to solve for x is subtract 1 from both sides. And I can't bring that into the logarithm, so it has to stay outside. And then I'll divide everything by 2. So x equals the natural log of 4 minus 1, all divided by 2. Now again, this is our exact answer. So on exams, I will ask you for the exact answer. If you were asked to approximate, you would plug this into your calculator or whatever technology you're using. So make sure you put the entire numerator in parentheses. So it'll be the natural log of 4 minus 1, and then you can close up your parentheses because we're done with the numerator, divided by 2, and that is approximately 0.19. All right, looking at letter C. So we can see the exponential piece is already isolated. So now it's just solving, changing it into exponential or logarithmic form. So the natural log of 9 equals 5x minus 1. Get the x by itself, so we'll add 1 to both sides. Again, that 1 has to stay on the outside. And I get that x equals the natural log of 9 plus 1, all divided by 5. So there's our exact answer. And I can approximate this by substituting it into my calculator, or again, whatever type of technology that you're using, and you'll get that x is approximately 0.64. So it's the same types of steps that you're using for solving logarithmic functions to do exponential functions, but instead it's isolating the exponential part and then taking the logarithm. And again, the reason that I'm changing it into logarithmic form is because I need to undo having this in this exponential part. Inverse of an exponential function is a logarithmic function. Let's look at a couple more of these. So we have 4 times 10 to the 2x plus 1 equals 21, and then letter D is 10 to the x minus 1 equals negative 13. So why don't you go ahead and pause the video, try to work these problems out yourself, and then unpause it and watch me do it to make sure you've done it correctly. All right, first step here is I need to isolate the exponential piece, which is this piece right here. So I'm going to subtract 1 from both sides, and then I'll divide both sides by 4. So I'm left with 10 to the 2x equals 5. All right, whenever I'm doing exponentials, again, I always look to see if I can write both sides of the equation in terms of the same base, and unfortunately, I can't. So now I'm going to change this into logarithmic form. So log base 10, which is just the log, of 5 equals 2x. To get the x by itself, divide both sides by 2. And we get that x equals the log of 5 divided by 2. And I can again substitute this into my calculator, or again, whatever technology you are using. And I can approximate this as 0.35. Looking at this next example, 10 to the x minus 1 equals negative 13. Okay, I'm going to do it how I think you guys most likely did it. I'm going to tell you a cool trick that you can see. So again, log base 10, which is just log, of negative 13 equals x minus 1. So I'm assuming most of you did this and then got the x by itself by adding 1 to both sides. And then you most likely inputted this into your calculator. And when you did, you got an error message, which means there's no solution. And why is that? Well, there's two reasons. One, you can look at this step and recognize right away you can't take the logarithm of a negative number. We define the domain of a logarithmic function for all values of x that are greater than 0. The other thing you could see here is 10 to any power is never going to be a negative number. You cannot put a positive number to a power and get a negative number out. It's just not going to happen. So in other words, there's no value of x that when I put 10 to that power, I'm going to get no solution, or negative 13, so there's no solution. All right, last part of this is looking at some applications. You're going to see logarithmic functions happen a lot in biology and physics. So let's look at a problem that deals with science. The pH of a chemical solution is given by the formula pH equals negative log of H+, where H+ is the concentration of hydrogen ions in moles per liter. The values of the pH range from 0 acidic to 14 alkaline. What is the pH of a solution for which the concentration of hydrogen ions, H+, is 0.01 moles per liter? So let's see what I'm solving for. I'm solving for pH. So that's my unknown. So that means I need to make sure I have a value of H+. Well, they told me that value is 0.01. So I will substitute that in. And now this is just substituting this into your calculator, and when you do that, you'll get 2. Now they're asking, what is the concentration of hydrogen ions? So now I'm solving for H+, so that means I need to have a value of pH that I'm substituting in. And a banana with a pH of 4.5. So it's 4.5 is my pH level, and I'm needing to solve for H+. So again, this H+ is stuck inside the logarithm, so I need to undo that. So the first thing I do is isolate the log. So right now there's this negative sign here, so I'll divide both sides by -1, and that leaves me with -4.5 equals the log of H+. Now that I have this log isolated, I can change it into an exponent. This is log base 10, so 10 to the -4.5 equals H+. Substituting that into your calculator, you'll get that H+ is 0.0000032.